Welcome to the Natural History Museum, the largest natural history museum in Europe and a world-leading center for scientific research. It is here that over 300 scientists care for 80 million specimens, a collection that enables research into every aspect of the natural world, from discovering new species to tackling biodiversity loss for a future where both people and planet thrive. I am about to be joined by 3 experts from fields vital to tackling biodiversity loss. We will discuss the importance and interplay of scientific discovery, conservation, education, and public policy in conserving amphibians. Together, we will learn about the progress made, but also the challenges that remain, while we get better acquainted with a species of frog with a truly fantastic, if slightly confusing name, the mountain chicken. So, without further ado, let's meet our panel. Hi guys, it's so great to be here with you all today. We're going to start with the sort of heavier stuff and then we'll get to some of the good news later on. I think just so that people can really understand why we really need to be concerned with amphibian decline. So Jeff, maybe you could start. Why are amphibians so important? Why should we care about them?
Well, I think one reason is they're a lot like us. They're vertebrate animals, but they're also not like us, and that is one of the reasons we should care about them, because they're not like us because most of them actually use their skin as a respiratory or breathing apparatus. And that means that their skins are very permeable so that they can facilitate gas exchange across their skin. That's great for respiration, but it also means they're quite subject to drying out. And it also means that they absorb toxins from their environment very readily. So that means they're very sensitive to environmental change. And in that way, they're kind of an indicator of ecosystem change. And that's something that we should definitely be taking notice of.
Yes, they're an indicator species,
that's
correct?
Right, yeah.
So what exactly is that, and why is that term so important to understand today?
So much like it sounds, an indicator species is a species that's telling us something is going on, right? And in this particular case, we kind of can think of them as a canary in the coal mine, that what's going on is bad, and what's going on is something that might actually impact us.
When did we realize that the amphibian communities were in decline?
Yeah,
this is not that long ago.
It's a great question. It isn't really actually that long ago. So in the late 1980s, 1989, there was actually this symposium of herpetologists. Those are scientists that study amphibians and reptiles. And they actually got together here in the UK, down in leafy Kent, for the first World Congress of Herpetology. And at that meeting, it was one of the first times that field biologists that work with amphibians all around the world got together and realized that everybody was observing the same rather alarming trend, which is that they were not seeing as many amphibians as they'd been seeing in previous decades. And so this kicked off several years of research to try and figure out what's going on. Is this a real phenomenon? And some of the early results demonstrated that the reasons for the decline were quite obvious: pollution, habitat destruction. But then there were some troubling patterns of decline, like amphibian species declining in pristine forests that had very little disturbance by people. And it was those observations that led to new fields of research in amphibian conservation, looking for possible disease agents that helped describe and document several diseases that we now know have been spread all around the world and are the cause of some of these declines. And a disease in particular that's been very bad for amphibians is called a chytrid fungus. This chytrid fungus, Batrachocatrium dendrobatitis.
I can't say that.
It's a mouthful for sure.
Now, Ben, you've been working to protect a particular species who's been hit hard by this fungus. Could you tell us a little bit about the species? And also, I think people would be interested to know just how quickly this fungus has really decimated that population.
Sure. So this is the mountain chicken frog. They're the largest amphibian in the Eastern Caribbean, so they grow up to about a kilogram in size. It's critically endangered. They're currently restricted to 2 islands, Montserrat and Dominica, and they were a very important food source for people. So they were the unofficial national dish on the island of Dominica, because they're such a big frog, they've got a lot of meat on them. And I guess a flagship or culturally iconic animal. So this species features on the coat of arms of Dominica. There's lots of kind of proverbs about the species. So it's a really, really kind of charismatic species. So a really important stakeholder that we needed to work with was the local community to get that kind of support.
Right.
For
but
conservation.
They don't actually live in mountains, right?
Well, the islands are quite mountainous, but we find mountain chickens kind of lower down, more in coastal elevations. But the name could come from the fact that they squawk when you pick them up. They emit a really loud call to kind of scare predators away.
Call.
Yeah, more like a chicken, I would say. Yeah. Okay. And so that's really, really loud, and it's quite startling the first time you kind of hear that, especially in the forest at night when you pick up a
I can tell you, if you're not expecting it the first time you pick one up,
it's shocking.
Yeah.
I'd love an impersonation, but I won't force anyone.
I can't do it. But one of the really interesting things about the mountain chicken frog is their reproductive mode. It's unique to this species, so the males call from underground burrows to attract the female. The female enters the burrow, they mate, they produce a foam nest, and the tadpoles develop underground inside this foam. It's like a giant marshmallow. And the female will feed the developing tadpoles infertile eggs throughout, and that's all they eat until they metamorphose and leave the nest. And because they have this quite specialised reproductive mode, they don't produce that many offspring because they just, they focus on providing a lot of resource to fewer individuals. So that could make them inherently vulnerable and make populations quite slow to recover. And we started seeing declines in mountain chickens in the early 2000s, so relatively recently. And the mountain chicken underwent what was probably the fastest ever documented decline of a vertebrate, which was caused by this disease. They're highly, highly susceptible to chytrids. So to kind of tackle this, we had to establish ex situ or captive breeding populations to kind of safeguard this population to a time when the threat could be addressed. We had the tools to address it. And unfortunately, at the time, there was no capacity to develop a conservation breeding facility in the Caribbean at that time. And neither were there. Because of the fungus? Because of the fungus, and because there had never been something like that needed in the region before. Whereas mountain chickens had been kept in captivity in European zoos for several years. So we actually were in a really good situation to rescue a population of about 50 individuals and bring them over to Europe. And in tandem, we developed a conservation breeding facility on the island of Dominica, and we developed a molecular diagnostics laboratory so that they could look at the wildlife diseases on the island instead of having to export samples all the time. And so it was a real collaborative project known as the Mountain Chicken Recovery Programme, which was in collaboration with the governments of Dominica and Montserrat. So we're now in a situation where we have these captive populations of frogs, and that's not sustainable to run indefinitely. It's quite resource intensive, so we need to start thinking about exit strategies for the mountain chicken frog. And one of the things we've learned about this chytrid fungus is it's susceptible to high temperatures, and it's also susceptible to drying out. So what we're doing as part of the Mountain Chicken Recovery Programme is we are sending captive bred animals from European zoos back to Montserrat, where they're functionally extinct now. There's no wild mountain chickens in Montserrat. And setting up semi-wild enclosures, releasing the frogs in areas where the habitat's been modified by humans, so it's kind of brighter, slightly warmer because we've reduced the canopy cover. And then we've trialled these kind of hot water baths, warm enough to reduce the level of infection. So what we hope is that this will allow for mountain chickens to persist in at least managed conditions on Montserrat for the first time. And what's really important is that this is just a simple system, but if we get it right, this means that this could potentially be scaled up to on conservation projects focusing on the hundreds of other species that are threatened by these diseases.
So obviously you represent the good news that human beings can be a part of the solution and in very creative ways, but obviously also we're here because of human activity that's been so destructive. Can we talk about some of the examples of things beyond this fungus, that human beings have done to sort of threaten these communities, but then also how the decline then affects human beings?
So there's a couple of really good examples, and one of the kind of really old-sighted ones is the fact that in many parts of the world people eat frogs and they collect them for for their legs. And in particular in India, lots of frogs were harvested from rice paddies for the meat trade. And then it was kind of noticed that as the frogs were disappearing, that lots of agricultural pests were appearing and yields of crops such as rice went down.
Because of course, the frogs weren't there to eat the pests.
Exactly. So
right.
You've lost your free pest control, basically, by
right.
harvesting those frogs.
Presumably you cause a greater problem because then you need to bring in all kinds of chemicals to kill
yeah.
the pests, which then, of course,
yeah.
harms the environment in new
and it's also probably
ways.
More costly as well for people
sure.
farming. And then recently, another good example is how in Central America, as amphibians have declined due to chytrid kind of moving through, that alongside those declines, not only did people notice things that were eating frogs disappearing, so snake community collapse, but they also noticed an increased incidence in human diseases.
Oh, wow.
So things such as malaria, where the mosquito is the vector,
mm-hmm.
and I guess the link is that the frogs were not there to eat the mosquitoes, which ultimately led to increases of disease in the human population.
And Charise, I imagine in your work this is the kind of information that is quite useful. Can you talk a little bit about environmental policy work and how you use this research?
Yeah, absolutely. So there are a few things that are really important to get to the attention of policymakers, and their inclination is to think more about economic costs, and it's always a money issue. Everything is always a money issue.
Sure.
It's like, where are we going to find the money from the budget to allocate toward this issue? But as soon as you connect it to public health and show that it's actually really going to impact not only humans, but then put a strain on our resources to handle that issue, that is when you will start seeing more action. So with policy, I try to explain to people that it's not just about, it's not just legislation, it's not just laws. Like, policy is education, policy
right.
is creating that awareness, and one way to do so is to share the cultural significance, to share your stories, and have case studies like that to present to policymakers along with the science.
And now I think probably people listening, I hope people listening and watching are wondering what they can do. Can we talk a little bit about, I don't know. I don't really know where to begin. I know, Charise, you're working a little in your community in this area, and there's some stuff, Jeff, you told me about what people can do at home.
Yeah.
Yeah.
Do you want to start?
Sure. I mean, on a small scale, just an individual who cares about things, cares about the environment, cares about amphibians or other species, there's so much you can do just in your own community. And one of those things that I'm trying to do right now is to help my community just to think more about their relationship to nature and what environment means to them, and from there start to get into deeper discussions. But one way that I am doing this is by creating a guide of just our community ecosystem. So all of the plants and animals that you might see inhabiting that space. We definitely hear the foxes at night. And just so people know, like, it's not just us there, and it's not just us that we need to be thinking about, because there are other species that are utilizing this space, and they're just as important. So just getting that awareness to try and take it to the next step to make sure that we're not hoarding information for ourselves. You know, it shouldn't. When you learn something, you need to tell the next person. Just keep sharing that information, keep passing it on, and that's how we will inevitably get some change.
I think especially people who live in urban environments, we can sometimes forget that we are still in a natural environment because you don't see as much of it, or maybe you don't smell the fresh air, but in fact there are these creatures living alongside us, and we can help, especially those who have the good fortune to have a bit of green space. I understand in our own backyards we can do some things to help. So Jeff, do you want to tell us a little bit about?
Yeah, sure. There's plenty of things you can do in your own backyard, your own garden, to encourage amphibians to be there, and also make sure that you're not hurting them by what you're doing there. So a couple of simple things are to leave your garden, be a little wild. So let your compost heap kind of overflow, leave cover objects around so that amphibians have places to hide.
They like a little bit of
They do, and
a roof.
They like a little roof, and it's also really important for regions of the world where it gets cold in the winter for them to be able to survive the winters to avoid freezing. You can also put a pond into your back garden. That's a great way to encourage a lot of water-breeding amphibians to turn up.
How do they find your pond?
They're very good at it. They've been doing it for millions of years. They're quite accomplished.
Got pond radar.
Yeah, and it's kind of critical for them, as we talked about their permeable skin. They need the water, so most of them are very good at finding it. Right. And other things you can do are really simple, like if you've got a pet cat, keeping an eye on it. They kill lots of amphibians every year just walking around in your back garden. And being mindful of what you're putting on your plants you've got in your garden as well. We know that pesticides act as endocrine blockers for amphibians and can really mess with their development. So just being mindful of if you are going to use pesticides, what pesticides you're using, educate yourself what's in them and whether it might be bad for amphibians or not.
I'm just thinking about the cat issue, because a lot of people that live in urban environments, they might not own a cat, but their neighbors might. Are there any kind of covers, or do you know if there's any kind of DIY work you can do to sort of have a pond, but
cat-proof it?
Cat-proof it, yeah.
Oof.
Is this getting a little too niche?
No.
I'm just curious.
Little frog door.
Frog flap.
No, I think probably the best strategy you would have would be to talk to your neighbors that have the cats.
Right.
So it is, that is a challenge if you live in a densely populated area. I certainly, where I live, that's a big issue. I don't know all of my neighbors, but I know their cats.
Right.
So yeah.
Okay.
Yeah.
To be figured out.
Yeah, to be figured out.
Some young scientist out there develop the amphibian frog door for us.
And that way it's not just Jeff in his back garden shaking his hand like this.
Great, so I don't think we have time for too much more, but I'd love to hear if any of you have a great, fantastic amphibian fact that you might want to share as we wrap up.
Yeah, sure. Yeah, I guess I'll start. One of the things I think is most fantastic about amphibians is, and a lot of people might not realize, is that while most amphibians have a biphasic life stage, where you get, they are born, they hatch out of an egg, and they spend time in water with gills, and then they, through metamorphosis, become more terrestrial as adults. There are loads of amphibian species that have done away with that altogether. They don't have tadpoles, they don't have larvae, we call them in the business. They don't have that. Rather, they lay terrestrial eggs, and their young hatch out as small frogs or salamanders or caecilians, whatever type of amphibian they are. And among those species, there are some incredible natural history traits that have evolved. That includes some species that lay the eggs on mom's back and the skin grows up over the back and they develop inside of her like that. Wow. Others that, kind of similar to Ben mentioned with the mountain chicken frog, that develop underground. And when they hatch out, the mother's brooded them, so she's a very good mom. They hatch out and they repay her by chewing off this thickened skin that she's grown. It's quite violent looking, actually.
So rude.
Happily, she survives this whole ordeal. But still, just fascinating behaviors have evolved for these animals to occupy in almost all but the saltiest, coldest, and driest parts of our planet.
Wow, that's awesome.
So that's my fun fact.
I still feel a little bit bad for the mom in that scenario. Does it heal? Or
yeah, absolutely, yeah. So in this particular case, the skin actually gets, it's almost been it's been compared to milk in mammals, kind of. So it's actually thought that the skin thickens as part of, because of hormonal regulation. So she's actually getting this for the young caecilians that do it.
Beautiful.
Yeah.
One of my favorite amphibian facts, which I will defer to the experts to correct me on, but there is a specimen here, Ambystoma, which I believe is the axolotl or related
That's right.
to axolotl, okay. And the axolotl just always, it's adorable and it always looks like it's smiling and it retains that juvenile phase throughout its whole life, and that's something called neoteny or...
Yeah, neoteny paedomorphosis facelift.
Yeah, and I just think that's amazing.
Yeah, I think there's a lot of people around the world that would love to figure out how to bottle that and sell it.
I am one of them. Yes.
My favourite fact about amphibians is probably just the diversity. Just incredible number of species. There are about 8,300 species of amphibians that are currently described or known, and about 150 new species are described each year.
Wow.
So whilst amphibians are incredibly threatened, and many of these new species that are described are also really threatened, it's just really quite exciting for me as a biologist that we can still make really cool discoveries about the species we share our planet with. And it's only by getting to know these species and understanding the true diversity that we can actually kind of conserve them effectively.
Right.
Yeah, keep them around for another 370 million years.
Exactly. Well, unfortunately, that is all we have time for today, but you can read more about some of the challenges faced by the natural world and the many, many ways you can help on the museum's website. I'd like to thank our brilliant panelists for your time today and sharing your great insights with us. I hope, like me, you enjoyed this discussion, learned something new along the way, and feel inspired to protect these extraordinary animals we are so privileged to share our world with. Thanks.